Good afternoon, everyone. Hopefully you can hear me. Can you hear me fine? Yes, great. So welcome to this DTCC lunch webinar. I will be presenting a summary of the data models for Digital Twin Cities project. I'm currently the host. I made Graham co-host to hopefully be able to admit people because I'm getting the admit notifications. I think it's working because so yeah, I will get started as people arrive, and Graham is helping me get people in. I've been project lead or co-lead with Graham Kemp on this project. It's a milestone project from the Digital Twin City Center. And why do we have this project? We had this project because a lot of the challenges that were encountered at DTCC when we try to create digital twins for cities are related to data and many aspects of data. That's why there was also a research area on data, RA7. Data access, data ownership, interoperability, quality, sustainability, essentially a wide range of issues related to data. And so we had this milestone project. And when we look at digital twins and discuss urban digital twins, often we see the shiny 3D models with simulations, animations, visualizations. But we will be looking under the hood. We will be looking at the data behind those and the models and data models behind those. So not so many sexy 3D images, but more technical diagrams, I'm afraid. Hopefully it will be interesting to all of you. So the project that I'm presenting had the main aim to study data models that are usable and useful for creating digital twins of cities, focusing on concrete cases and looking how these data models can be extended and especially linked. Also how they can be based on open standards, specifications, and ontologies. And here on the right, we have some logos of the various partners that were engaged at various stages of the project. This project ran over a considerable long time. So there were some partners that came in late, others dropped out halfway through, but we had input from a wide range of partners from academia, public sector, and industry, which was great. And the project had 5 main work packages. One focused on surveying needs and resources of these actors. Any actor really interested in using and developing urban digital twins, the data models that are necessary to make these digital twins work, databases to hold and manage those data, and some use cases and applications, of course, dissemination, such as this webinar. One important thing that became clear right from the start is that there's a lot of technical terminology, especially when we discuss aspects of data. And we are actually developing a glossary of terminology, and you'll hear a lot of jargon. I can already warn you during this presentation. So yes, we are putting together some of these words in a glossary, and then we will disseminate that as well so that people more clearly can understand and enter this world of data and data models in digital twins. But back to the work packages, and the first work package, which was about needs. The question is, what data does an urban digital twin actually need? And with that in mind, we developed a methodology for gathering data requirements for urban digital twins. One tool that we introduced, inspired by Graham's experience with databases and data requirements for database systems, was this idea of these 20 questions you would want to ask a digital twin. So rather than asking what data do I need, is asking what do I need from a digital twin? What do I need the digital twin to do for me, and what questions I need to get answered? And by inverting this, rather than having a long list of data sets, we have a long list of questions. And from then, we apply this method with various people at workshops and also through use cases. And you can immediately start seeing that a digital twin can actually have questions related to a wide range of use cases related to urban comfort or materials or economy and investment in buildings or energy, etc. We had a partner that was from Västra Götalandsregionen, from Västfastigheter, that have responsible for the different hospitals. And so we decided to focus on a specific use case of the hospital campus and the specific case of Sahlgrenska. So from that partner, we got a set of 20 questions of what are the burning questions that they have when it comes to handling the hospital operations and what they would hope that a digital twin could help with. And these questions so the methodology starts precisely with these questions, and then we develop some diagrams to understand what information is required to answer those questions and how this information is linked. From that, we can develop or identify the specification of the standards that are required and identify existing or new data that can be used. So this is the core steps. These are the core steps of the methodology. And so when it comes to this hospital case and looking at those questions that were asked, we could identify immediately already a range of 6 different knowledge domains or topics: visitor parking, traffic around the hospital, food waste, and construction and maintenance of the facilities, the actual use of those facilities, and the energy consumption of the different facilities. So of course, there was a lot to discuss, and we had workshops as well to go through the questions one by one that were asked, and then unpack those questions into the information that those questions are about. So when it comes to traffic in around the hospital, of course, it's vehicle traffic, but it's also flights of helicopters, emergency helicopters, and potentially drones that are being used to deliver urgent material to the hospital. But of course, vehicles that are for service vehicles, maintenance, but also ambulances and visitors, etc., etc. And this links to buildings. So the first step was a process of unpacking those questions to understand all the information that is needed to answer those questions and creating these relationships between questions. So it was very interesting to develop, and really this allows us to understand and get then to the question, what data do we need, or what standards should we use? So this use case was mostly used to demonstrate this methodology and to come to a specification of what the hospital campus could do with a digital twin. We also tried a small pilot of implementing one of these aspects of building utilization, and our partner tried in their facilities to get a pilot system working to monitor the usage of different rooms. But it was interesting to find there were very strong barriers to the implementation of a prototype, both institutional, so the institution itself was raising a lot of legal and privacy restrictions, a very complicated process to get even things to be installed, and a certain resistance to change. On the other hand, there were technical barriers because there are already a lot of path dependencies with the existing systems, and trying to use off-the-shelf solutions had features restrictions as well that were not either allowing for the knowledge to be retrieved that was used, or not allowing it to be connected to the data coming from existing systems. So indeed, this stayed at the specification level and mostly demonstrating the methodology that we have developed. But of course, once we know what we need, comes the question, so what data models should urban digital twin use? And we got that a lot. So what data models should we use? What standards should we use? The first thing we had to clarify early on in the project was the difference between a data model and a file format, or a data model and a data format. So here what we see in this slide is just a bunch of information about a person, an individual. A data model is how the information about that individual relates, the person, its telephone number, the address, the relationships between these pieces of information, the details of each element of this information. This is what we mean by a data model. And that's why you are seeing those diagrams in the previous slides when we were unpacking the questions. When we talk about file format or data format is how that data or information is encoded. For example, here we have two examples of exactly that same information that we saw in the previous slide, but just encoded as a JSON file or XML. So for us, this is not important. This is just a matter of like how you write that information. For us, when we talk about data models, we're talking about how the data is organized, what information we have, what the relationships are. And going back to the question, what data model should we use or what standard should we use? Actually, there are hundreds, maybe even thousands, to be honest, of open, some not open data models, specifications, and standards out there. This slide just shows a list of all the organizations that are publishing standards, and many of them useful to developing digital twins. Some of these, like the Open Geospatial Consortium, is the organization behind CityGML, for example, and many other important data models. The World Wide Web Consortium itself has, for example, a building topology ontology, which is also used in digital twins. Fireware is a key one that has a range because it's focused on IoT, smart cities, and digital twins. Most of their data standards and data models are relevant. So this is just to give you an overview of the landscape. And to be honest, it's impossible to map and trace or list all those standards also because they're constantly evolving and being developed. This is an extremely dynamic field, and it's not possible really to trace all the standards. So conclusion is one should just use open standards from the specific domain that is relevant. We as individuals need to identify the relevant ones from our domain because it's a huge list of existing standards. We should not reinvent the wheel and start by creating a new data model. So once we identify the needs, we should identify the standards that are out there. Sometimes, eventually, it's possible that there is no appropriate data model or standard. But in that case, we should make a minimal model with hooks and specific hooks to other models that exist rather than overlapping existing data models. Examples of these is, for example, when one creates CityGML extensions. So CityGML is a data model that focuses a lot on the physical infrastructure, like buildings and roads, and people create extensions for energy. The Gate Institute during this project created an extension for the trees, for example, for representing trees with a lot of detail for ecosystem services analysis. For example, the building topology ontology that I mentioned earlier has a series of alignment modules. So it describes the buildings in a certain way, but also makes the effort to link those descriptions to other standards. So by linking standards to other standards, all of a sudden we realize we can just limit ourselves to describing the elements that are important to us and use as much as possible existing standards. Another thing that we've learned in this process is that ultimately AI together with ontologies will solve the interoperability. So we should not worry, are we selecting the right standard? As long as it's standard and as long as it's open, it will be certainly very simple to align it with other standards and make it usable in digital twins, because ontologies can align data models. There's work being done into that, and also AI is very much being used for aligning data models and also for converting data formats. That example that I gave, the same information in JSON and XML, if you ask ChatGPT to do that, it probably will do it perfectly for you. So in our project, we actually only did one specific, domain-specific data model that was related to waste and resource flows because there was not a data model from that domain. It's a domain where digitalization is quite behind in a way, and therefore This data model was required, but the idea here is not to go into roads, buildings, and other domains that are already pretty well covered. And so these call-out boxes are just saying elements where this can call out and link to existing data models. So this was one part. Going from needs, what do we need? What standards should we use? But then, okay, how do they bring this together? How we make urban digital twins for cities? And here we started looking a lot at data spaces and the ecosystem where these digital twins can exist. Essentially, cities are extremely complex. They have a lot of systems in them. Um, it's not just when we look at 3D city models, we see the buildings model, the terrain, the water, the sky, some trees eventually, but cities go a lot beyond that. So we need urban digital twins that represent also environment, the social, economic, energy, transport, materials, climate, so many other systems in the urban system. Also to be able to do different kinds of simulations or to show us the baseline, to predict future scenarios, etc. So this is what we expect from an urban digital twin. Therefore, we need lots of different data. How do we do this? How can we maintain such a digital twin? And this is where the idea of data spaces comes in. So we argue that digital twins can work in this way if they exist in this environment of data spaces where we have linked data and they can connect to this, let's call it live data. Let's just say a bit about data spaces. So data spaces is a federation model of data sharing that is being proposed by the EU. And as since the European Strategy for Data, there's an enormous amount of initiatives from the EU and funding from the EU and to implement these data spaces within countries and even across countries. There's now a series of initiatives to create data space infrastructures that are international. And so these data spaces are domain-specific collections of data where different actors, they can be data providers, they can be data users, they sign up to the data space precisely to provide data or to access data. And everything is regulated by this data space infrastructure that regulates it in terms of the exchange of data, the access to data, the transaction itself. And of course, these data space connectors that you see in these black boxes are exchanging the data using standards. So back to the standards that I mentioned earlier. So it's a regulated and standard environment where different actors can securely share information and exchange information and data. So this is what the infrastructure that is being created, and it has hundreds of actors. So the idea that one creates a digital twin and goes around finding data, knocking on doors, establishing protocols with individual data providers, it's quite naive in a way, because there's hundreds of data providers out there if we really want to have digital twins of cities. And also we will have multiple digital twins for different domains. Therefore, we can't expect the developers of each digital twin establishing all these protocols individually. That would be a huge waste of time and resources. For that reason, these data spaces are being created so that the exchange of data becomes regulated, secured, and facilitated. What we go further in our research into saying is the image on at the bottom, where we introduce a new role coming from the notion from the domain of federated databases and federated database architecture, which is a mediator. So one thing is having all these individual actors, providers and users connected to a data space, but how do they find each other? How do they actually link the data that each other is providing? So the mediator has this role of actually cataloging on the one hand, but also linking the data provided by the different users. Someone might have data on a road or a building or a lamppost, the data sets are completely independent. But with a mediator linking the data, someone that is interested in information about those three features, like a data user developing a digital twin, would obtain that information already connected and linked. So this is an important role, this mediator role. And what we argue, and this is part of a paper that we are currently trying to get published, we submitted the revision already, so hopefully it's out soon. So in this work, this research and this paper, what we argue is that this mediator role is precisely a role that a digital twin, an urban digital twin, can play. So what is the role of urban digital twins in this ecosystem? So on the one hand, the ecosystem provides the data and gives the digital twin access to all kinds of data. At the same time, and data from different domains. Here in this diagram on the left, the blue and the green spaces indicate, for example, two different domains. Let's say the blue domain is a transport or mobility domain with a lot of actors providing data about transport related issues. It could be roads, traffic, congestion, vehicles, etc. And on the right, let's imagine it's a health related domain, hospitals, air pollution, and other aspects. And so we can have an urban digital twin that can answer questions about the performance of a city in terms of traffic safety and public health, connecting as a mediator the data from these different providers, and therefore providing to the users linked data that can answer quite sophisticated questions that one would not be able to answer just by connecting to an individual data set. So this is the role that we see going forward for urban digital twins, that not only benefiting from data spaces, but also contributing to those data spaces. And we are putting this forward to the data space community that urban digital twins and digital twins in general can play an important role there. And so what do other actors in this data space would look like? So actors that are data providers, they have their own system, data storage, and their data, and the connectors are there just to share data across the data space with users or the digital twin that are interested in using it. And the data provider, for example, can even connect to a municipal data that does not want to be part of a data space, but has important information that can be shared via a data provider. At the same time, data users or recipients can collect data from the digital twin and do calculations, simulations that then inform citizens or inform planning decisions. So it's a way of structuring and regulating access to information, but also connecting all the information needed for cities. One final case that we looked at was then, okay, now we understand the conceptual part of all this. How do we actually implement this? So we have a quite simple use case, which is about urban district multi-simulation, where we have multiple users that want to do different kinds of simulations in an urban district. And each of these requires different input data, simulation tools, visualizations, or different kinds of interaction with the results. So what we found is that the key for these is the data exchange between the different actors. So it goes back to the idea, the previous images about the data spaces and the actors in the data space. In this use case, we looked at how at the DTCC way of doing simulation is drawing specific kinds of data, having a pipeline that simulates and processes that data and then simulates and calculates different energy, noise, and wind simulations, and then visualizes the results in the DTCC viewer. So this is a specific pipeline that works well for this actor in the data space, let's call it. While we have, for example, from Lund University, another partner, they have a different way and a different focus on their simulation. So they have other tools to make the simulations. They have 3Sim, which is a Swedish version of CityGML to do those simulations, and they want to visualize the results. And they want to know, how can we use the DTCC simulations in our pipeline? And so essentially, the conclusion from our meetings was that these two pipelines, they are not necessarily incompatible. It's just a matter of finding, and that's what these red arrows indicate, the right data standard to exchange from the inputs or outputs of one pipeline feed into the other one, so that if the Lund on the left, let's call it pipeline, has a certain model that serves their purposes in terms of visualizing and making design changes and specific kinds of interaction, we can use a standard to communicate with the DTCC pipeline that produces the simulations and in turn returns that information back using a standard back to the Lund model. So standards and that data exchange are really key, rather than trying to align pipelines, which is super complicated because people use and have preferences for different tools and they have different needs. Finding ways to exchange the data is really the key. And what we hope, of course, is that with this smooth exchange of information and data and the existence of these urban digital twins in these data spaces with many actors and the rich live data, then we can actually create this physical virtual loop where the digital twin is very tightly coupled with the physical, with at many levels, not just as a 3D representation of the physical aspects, but really coupled in many ways to the data that exists and is being collected on the physical. So this is our vision. Thank you for your attention. I guess I can take questions as well, since there's a few minutes left. Let me stop sharing so I can see you. Yes, Elena, feel free to switch on the microphone and ask.
Yeah, hi, thank you so much. It's a very interesting presentation. It's actually first time I hear in more details about this project. My question is about metered data, or like debate about digital twins today are very much relate on the simulated or aggregated data.
Yes.
However, if we go to the like original tradition of digital twin, it's supposed to have this feedback between physical world and
Completely.
digital. What is your vision or points about this more like infrastructure for environment metering and stuff like that?
I mean, those actors that have that data are definitely actors in those data spaces. So what I expect is that people that are collecting that data, they join data spaces. Data spaces, I've shown them here, are quite abstract, I admit, but they are being implemented, as I said. A great example that I know of is the mobility data space in Germany that already has dozens of participants. And when it comes to metadata, there are participants there that have real-time data feeds on traffic speeds, traffic levels, or weather conditions on the road. So it's not necessarily building level meter data, but it's sensed data being fed in real time to the data space. So if you join that data space, then you adhere to the protocols and you use the standards, you can access that data. And then that's why we argue that if a digital twin connects to the data space and becomes a mediator there, then gains access to that data. And only then we can realize, as you said, this vision of the loop, the loop of data, real-time data being used in a digital twin.
And maybe just to connect that, I really think that you show a very nice diagram when you like show this digital twin in the center and then like four kind of dimensions or
Yes.
different. So it would be really nice when you move to the next image with this actors representation. It would be nice to see what is the distribution between simulated actors
Yeah.
cluster or physical world actors
Yeah.
cluster.
Yeah.
That's interesting
I
to
mean,
see.
that will be very much domain specific. So maybe, I mean, that's an interesting suggestion. How do we describe for example, let me take the case of the mobility data space I mentioned. how can we map that data space into that more conceptual diagram? What are the different actors' roles, and what kind of data do we get, and what kind of connected system of the physical and the virtual can we actually achieve?
Yeah,
Um,
looking
so
forward.
yeah, that's so. Thanks for the suggestion. I think that's a useful step in making the conceptual more concrete. Thank you. Any other questions?
I have one.
Please, Anders.
So are there any like big questions, sort of outstanding questions that you feel you haven't been able to answer these first 5 years that you think are like pressing questions,
Yes,
interesting questions to push on with?
completely. I mean, we started with a very different set of questions, and some of them, as I said earlier, were quite naive. Like, should we make a list of data sets?
Hmm.
That was a question that we had at the beginning, and almost a task that we had. Oh, let's make a list of data standards and data sets. But quickly we realized that's a naive question because there's just too much out there, and it's very domain specific. So I think what we ended up is actually with a completely new set of questions, and a lot of these things I've shown, as you can see, they are very conceptual at this stage, and I would say even at the EU level, and we are part of the local digital twin forum. Um, these things are actually happening now, being developed, being implemented. So all that I've shown that is conceptual is not necessarily an answer. It's a way forward that is full
Hmm.
of questions. How do we actually implement this? What standards are these different connectors going to use? Different actors, as they engage in the data space, they have to answer their own questions as well. Which standards do we do? Who's implementing these connectors? I know that Fireware and a lot of the agencies are developing the infrastructure, so that is happening. But indeed, it's still evolving field.
Hmm. So in what extent should one sort of thinking strategically? To what
Hmm.
extent should we involve in the development of these data models and standards? Because I feel that if you get involved with that, it's like that will take all of your time.
No, I don't
Then you
think
have
it's so
to.
much. I don't think it's so much the development of the standards. I think there's plenty of people doing that.
Mm,
Also, I don't think necessarily developing the technology for data spaces, because, as I said, it's more of a market brokerage security technology. So it's
mm,
less about the digital twin. I think that is happening. It's like it's a fact of of
yeah.
life. Let's put it this way. And there's a lot of agencies doing that. What I think they're not doing necessarily, and the local digital twin forum is taking note of that, is this role of the digital twin as the mediator. So the ecosystem is now growing and being developed, but what role the digital twin plays in that ecosystem so that it can actually become a catalog. So ways of hooking up. We developing digital twins, let's put it this way, should learn how to hook up, connect to these data spaces,
Mm,
should learn how to retrieve data, well, based on the standards that are being used, that
mm,
are
mm.
global standards, and how to link that data to answer our questions, the questions
Yes.
that
Mm,
digital twin users have. So connecting to data spaces, linking the data that all of a sudden becomes available, unlike the struggles that we've had to get data from Landmateriet, for example.
yeah. Yeah. Mm,
So once we connect to a data space and we are clients of that data space, then all of a sudden those data providers are at our fingertips,
yeah.
unlike what we had in the past. So connecting there, how to connect there, how to link the data, and give back that catalog that of linked data to the data space as a service, because that's also a value. But of course, and then continue once we have that linked catalog, continue with the development of the interfaces, interactive visual interfaces to that, and the simulations, etc. So that can continue, but based on a connection to a linked and live catalog of data that is provided by these data spaces. I think this connection is something that we really need
Yeah.
to pay attention to.
Okay, great. Thanks.